Hello, Ian here. Victor Kilo 7, India Alpha November. Look at this. PCBs have arrived. Yeah. Very nice. I went for the purple. I really like the purple colour. Yeah, they took a couple of weeks to get here. And in the meantime, I've been winding coils, winding the toroid coils, and what I thought I'd do is build it in stages, and yeah, I'll start with the TSSOP parts here. I'll put those on first, because they're the trickiest part. But what I like to do is placement is key for surface mount. So what I do is I use my dominant hand to line it up and tack it down, and then switch back to the other hand to finish up the soldering. But these ADC and the DAC are powered from the FPGA dev board here. So I'll put those two components on first and then progress to the power supply parts and go from there. So that's the plan. Okay, so I have the AD9236 tacked down. Just need to, and lots of flux, and just need to finish off the soldering. There we go, finished soldering the ADC. I'm not sure how well that comes up. Okay, I will do the DAC on the other side. Okay, the DAC is tacked down. Just add some flux and finish off the soldering. There we go. 89740 is in. No issues. We'll carry on. Okay, I've installed the common mode choke and the power connector and a couple of capacitors. I just want to double check polarity and voltage is getting through properly. I've set up the power supply at 50 milliamps. Doesn't need to be more than that for this test. So plug it in. No smoke, that's good. Check the voltage here. Yep, 13.8. Voltage on the MOSFET point here. Yep, good to go. No problem. Good to go. Just installing the rest of the power supply parts. But before I put the parts in, I like to measure them. So use a 22 capacitor, 22 microfarad capacitor. Close enough. Close enough. Close enough for Australia. I just wanted to show you the C0G type capacitors. They test much more accurately than the other types. $100 nanofarads, no problem. All right, I've got the MOSFET protection in. and associated parts. So let's do another voltage test before we put the 5-volt regulator in. All right. Ground connection. We should have, yep, 13 there. MOSFET should be 13, it is. Yep, and this pin should be about 7. Oh, sorry. Yep, that's about 7 because of the resistor divider, and then we have output. Yep, input to the regulator. Yep, there's a 10 ohm resistor there, 2 watt 10 ohm resistor. There's no current drawn, so that's about right. Nothing there. That's the output. Yep. Looking good. Let's put the regulator in. Okay, got the 5-volt regulator in. Nice chunky regulator. Let's go for the smoke test. Five volts here. Yep, we're okay. So the inputs come down a bit because of the 10 ohm resistor. That's cool. There should be 5 volts. Also here. Yep, we're good. So what I might do is put this the transmit regulator in here while we're in this area. Just get that in there with that capacitor. So this is the transmit 5 volts, and I'll put that in with this capacitor. So I put the bypass capacitors for the ADC in, and the bias components for the transformer, and the high frequency filter here. So what I'll do next, I think, is I will install the components for I2C, all the I2C devices, because so there's these 2 ADCs here for the SWR meter, SWR and power, and the port expander here on the back, those I2C devices, and probably all the other passive parts on the back as well. And that means we can then put in the Pico, and the Pico should then report with its self-test that everything's fine apart from missing the FPGA. So it'll check for the I2C devices, and if they're all fine, it'll move on to the FPGA, and then it looks for the data ready signal from the FPGA at 31 kilohertz, and then it'll flash an error on the LED, the Pico. So that's the plan. If you're having trouble working out which way round the diode goes, well, you can test it and it tells you. Just have to remember which way around it goes. All right, that's the 2 I2C ADCs on the top side. So we need to put the port expander on and the rest of the passives on the back, and we should be able to put the Pico on and do first test. I've got all the passives on the back now, but before I put the I2C expander and the relay driver on there, I just want to double check the voltages. So we'll plug this in. 4 milliamps, yep, we're okay there. Okay, over here, 13 volts, yep, that's the 13 volts to the transmit 5-volt regulator. Yep. Over here is the 13 volts to the relay driver. Yep. And there shouldn't be 5 volts. Yes, there should be 5 volts to this diode to power the Pico. And are there 5 volts here, 5 volts here? So I've got the polarity of those diodes right. That's 5 volts to the FPGA. Okay, we're good. Carry on. Here's one final check. I just want to check that 3 volts is going to go to the TCA port expander, which it will get from the Pico here. 3 volt out. Is it going to go here? Yep, we're good, no problem. Just wanted to check that. Oh, that's interesting. The ULNQ2003 doesn't have a dot to show pin 1, but the whole side has a notch, which is unusual, but hey, always pays to double check these things. So the port expander and the relay driver are in, so we can go ahead and put in the Pico and see what it reports. All right, I've got the Pico in and increased the current a bit. 150. Let's just make it 100. Oops, sorry. It's a 100 milliamps. That'll do for the power on. Oops. Sorry. This in. Okay. Okay, 4 flashes. This program's running and it's saying, we're reporting that the FPGA is missing. Now I just double checked the code. It doesn't go any further if it detects that the FPGA is missing. And but we're okay. It's 40 milliamps, so not a problem. I'll just check the 3 volts. I'll just check there's 3 volts going to where it's needed. Yep. Okay. So carry on, I think, with, I guess we put the FPGA in and then the display on. Yep, let's do that. Okay, the FPGA is in. So I'm going to set the current. I've already set the current 300 because the FPGA, that draws a couple of 100 milliamps. And we're going to plug it in. And we should see no flashing errors, hopefully. Yep. No errors. Okay. And what's the current? 200 milliamps, 230, okay. We're okay. Cool. All right. So what I might do is check for some signals, check for the right signals on the FPGA. So we should have 30 kilohertz, 80 megahertz. Well, they're the 2 critical ones. So let's do that. Okay, so what I want to check for is the 31 kilohertz data ready signal and the 80 megahertz clock. So I'll just set you up over here on the Rigol, and we're just going to check for 31 kilohertz. All right, 3 volts, 31.250, perfect. Nice. This on the right pin. Okay. 80 megahertz. Just get this on the pin properly. 80 megahertz, and okay, it's not a square wave because it's a 100 megahertz scope. It's as good as we're going to see it on a ×10 probe with a 100 megahertz scope. So 80 megahertz is there, 31 kilohertz is there, and we're good to go. Let's put the display on. That's what I think. All right, got the display on there now. And we will give it the test. Where's the power? Where's the power? All right. What have we got? Oh yes, it's looking good. Yep, nice, okay. They're in good shape. So there are no controls. I might add those. I might add some of the controls, the tuning next, so we can, at least verify that we can change the frequency. But what this means is there are no errors. All the I2C devices should be working. We're getting signal from the FPGA and the display, so that's really positive. So what I might do is finish up here. This will be the finish of part 3, and I'll do another video, start another video. I don't want this to be too long. So thanks for watching. Victor Kilo 7, India Alpha November. Yeah, take care.